Advanced Financial Modeling, Topic 12, International Finance. Learning objective number 4. We're going to hedge foreign exchange transaction losses. So suppose, as an example, Ingersoll Rand, a U.S. corporation, enters into a contract to buy 100,000 euros worth of equipment from a German firm when the exchange rate is $1.10 today, but delivery is 1 year from today. However, when they go to pay the invoice for the exchange rate is now 130. So you can say at the time they enter into the contract, they are expecting to pay 100,000 euros at $1.10. They're expecting to pay $110,000. However, when the contract came due and they actually bought the euros to satisfy the contract, the exchange rate was $1.30, so it cost them $130,000, which is $20,000 more than they expected. So we can do a formula. We talk about that $20,000 as a transaction loss. So there's a direct formula for calculating transaction gains or losses. Take the value of the receivable or payable, where receivables are positive V and payables are negative V, and take the change in the exchange rate, the initial exchange rate and the new exchange rate when the contract came due. So if I had my 100,000 payable, represent that as a negative, and that's in euros, times the change in the exchange rate. Remember, this is dollar per euro minus dollar per euro. Again, euros cancel out here, and it gives me a dollar number, and I can directly say that I lost 20,000 on this transaction. So how could I hedge this? Well, you could have done a few things. You could have bought $100,000 euros at the beginning of the year, deposit in a German bank, earning interest, and wait till the bill's due. That's one way of doing it. But you could also enter into a forward contract where you enter a forward contract to buy 100,000 euros at the forward price on the expected payment date. Another thing you could do is enter into an option contract. Buy a call option to purchase 100,000 euros at the strike price or a strike price on the expected payment date. However, with an option, you're going to have to pay the premium and you're going to have to get a valuation of that contract. Now, the Black-Scholes model can value currency options. However, to do it, you need to do two things. One, make sure when you enter in the spot price and the strike price, you put them in direct terms. Even if the exchange rate is an indirect one, you need to convert it back to a dollar price of the foreign exchange. And where it has dividend yield, because this model is built for stocks, what you need to plug in there is the foreign interest rate. The concept there is if you hold a stock, you get the dividend yield. If you hold a foreign currency, you receive interest in a local bank. So here are the Black-Scholes call and put functions. And here is the example. I'll go to a spreadsheet where it says BS1. Here's a spot, say the spot price of the euro is $1.09. You want a $1.09 strike price to buy euros 1 year from now. Say euro interest rates are 2% and the volatility of the exchange rate is 12%. Black-Scholes call price is 4.6 cents per euro. So for every euro you pay in this contract, you pay 4 cents, and the value of the put is 5.69 cents. However, if I wanted to value a call and put on the yuan, Chinese yuan, and say the spot price is 7.15 yuan per dollar, in the Black-Scholes model, I'll do 1 over 7.15. So now this is the dollar price of yuan. I went in and put in the an at the money value there, 1 over 715. I put in the Chinese interest rate here, and the risk-free rate is always the US interest rate, and I got a call price and a put price. That's per call or put on 1 yuan. So now what I want to do is show an example how to set up a hedge and simulate a hedge. So I'll make up this fictional company, MNC, Multinational Corp. It produces its products in China, paying CNY, and it sells its products in Europe, receiving EUR. All right, so it's got it has Chinese costs and euro revenues. I'm sorry, yes, euro revenues, but also has a little bit of US cost too. So what's their expected profit? Well, let's go to the model, MNC, and you can see the spot price of the euro is $1.10, And we'll say the spot price of the Chinese in direct terms is 6 yuan per dollar, in indirect terms, so I did 1/6. Let's say the expected appreciation of the euro is minus 2%. Expected appreciation of the Chinese is 2%. And so I have the expected spot prices for both of them. And these are now in direct terms, and say we'll worry about the volatility later. So we'll say that the revenue is I expect 105,000 euros in revenue, and I'm going to expect it to pay 350,000 Chinese is my cost, and there's also US dollar, say G&A costs. So I need to, obviously can't add up euros, dollars, and Chinese. What I need is convert everything to dollars using the expected exchange rate. So I'm going to use the, at 107.8, the expected dollar price of a euro, that is worth 113. At the expected Chinese, that's worth 59. Here's 40,000 US. So I'm expecting 13,690. Okay, so this is the problem. This is the situation. Now the question is, how could we lose money on this? Well, sure, these exchange rates have volatility, and if the euro devalues and I get less revenue, or the Chinese appreciates, I could lose a lot of money. So what we're going to do is we're going to set up a hedge. But before we do that, let's go ahead and run a simulation on the unhedged value. So notice back to the spreadsheet. I now have a simulated euro. It's today's spot times 1 plus the negative 2% appreciation plus random z times vol. And then the same thing for Chinese. Now every time I hit F9, I get a new simulated exchange rate, assuming that the exchange rates are normally, changes in the exchange rate are normally depreciated or normally distributed. Now I have simulated cash flow. Well, that 105 is going to change based on every iteration. That 350 can have a new dollar value based on every iteration. So now every time I hit F9, assuming that the two exchange rates are uncorrelated, I get a new profit. And then I created a macro to copy this number 10,000 times. And on average, I expect 13,569, which is about the exact same value here. So I didn't really learn much. But what I did learn is there's a 5%, the 5% largest cash flow is 40,000. And there's a 21% chance the cash flows are less than zero. So there's a 21% chance of losing money. So what if we determine that I could go bankrupt if I lose money? Well, we could enter into a hedge. So here's one possible hedge. MNC negotiates a forward contract to buy 350,000 Chinese at 612 and sell 105,000 euros at 107.8. Remember, this firm needs to buy Chinese to pay the labor and sell euros as they get euro revenues. So we're going to simulate those two hedges. I'm going to go to MNC forward here. And all I've done, everything else here is the same, except I've entered in a formula here that for my long forward to buy Chinese at 612, here's my simulated exchange rate minus the forward price. Assume they negotiate a forward price of 612, so it's 1/612. These always have to be in direct terms. That's why this is in dollar terms, and this one is converted to dollar terms. And this is times this is since you're buying, you're paying the 350,000. All right, here's the payoff of the short forward to sell euros at 107.8. Here's the F minus the simulated spot price times my 105,000 euros. Now, every time I hit F9, I get different exchange rates, but notice what happens here. Since I am fully hedged, I am guaranteed of selling all of my euros at $1.78 and to buy all of my Chinese at 612. So what you see, I am perfectly hedged. Any increase in cost will be offset by a profit here from the forward, and any decrease in revenues from my euros will be offset by a contract here. So it's kind of interesting that when you run the simulation, you are fully hedged. You're guaranteed $16,000. The 5% highest is $16,000. The 5% every number is actually $16,000, and there's no chance of going bankrupt. But I did have to give up some of the upside. One more simulation. What if I do it with options? What if MNC buys a call option to buy CNY at 612 and a put option, I should say put option to sell euros at 107.8? So I'll simulate that. I'll go to my option hedge. Notice I also have to put the cost of the options in here. So what I have here is for the call option for the Chinese yuan, max 0, and that's a simulated spot price minus that strike, minus the cost of the option, and that's going to be my profit. Notice I have the cost of the put here and the cost of the call here being valued by Black-Scholes. And then here is the profit of the put option on the euro, max 0, and that's the strike price minus the spot price, simulate spot price, and here's the cost of the option. Now, when I run this 10,000 times, I get more upside, but there's no chance of losing money. All right, there's no chance of losing money, and the mean cash flow went down a little bit because I had to pay for those options, but the 5% highest is much better than hedging. So I have a little bit of my upside, but I have no chance of going bankrupt. So this is hedging, foreign exchange, receivables and payables, and simulating that.